All right, welcome to the school year. I'm Mr. Cortez. This is the first video you could potentially be watching for Integrated 3. I'm glad you're here. Of course, these videos are used as an extra tool you can use in your toolbox if you feel as if there was something you missed in class or you just want to be moving ahead in material. That's totally an option. We're going to be reviewing a little bit here, comparing linear, quadratic, and exponential graphs. So what do those look like? For those that did some other cool stuff over the summer, you might need this refresher. Linear, think of it like a line, straight line. Quadratic, you learned about this in integrated 2. It's got that U shape, sometimes that downwards U shape. Exponential may start small and end super large, but there's also the option to start super large and end super small. This type of equation takes on this form occasionally. Quadratic may take on this form. Well, how do you see that? Usually you have a times x, and then it's probably squared. Maybe some other x terms in there too. Linear, mx plus b. That's what y equals. So we're trying to decide on how these equations here are going to work. I noticed that this table is all out of order, which you can put it back in order. That might be the best approach here. So I'm going to, on the side, say that if we had our first term as 1, that outcome would be -1. If the second term was 2, that outcome would be 2. If we had our fifth term as 11, it would look something like that. I don't know if it's going to be increasing in a linear fashion or quadratic or exponential, but let's just take a gander, kind of use our tools. Let's say that it was jumping from -1 to 2. And this is the first term and second term. Again, I'm doing this because it's not in an organized fashion. So maybe let's just take a stab and say that it's going to be adding 3 every time we increase by 1. So what could that look like? We could say that this rule starts at -1 and keeps adding 3 x minus 1 times. We could check to see if this is going to work for 2. So let's just check f of 2. If the n was 2, you would have -1 plus 3 times 2 minus 1, which is -1 plus 3 times 1, which is just 2. So that could work. Let's try it for 5 and see if that matches. And then we should be able to decide that this is going to be in a linear fashion. So same song and dance. Instead of x, I'm putting in 5 just to test run this. -1 plus 3 times 4 is -1 plus 12, which is 11. So lo and behold, our rule is good. You could just plug in these numbers and figure out what that sequence is going to look like. You could pop back to the 0 term and just deduct 3. So we're making this -4. What else could we knock out? Halfway between 1 and 2 was 1/2. So this would be adding 1/2. So this would just get you to 0.5, which makes sense because if you add 1.5, it's going to take you to 2. You could write these other increments out if you'd like, or just use the rule. I'll leave that up to you. What else do we have here? We have so I sketched this next one out. I noticed that we have a 0 term here, which we can consider to be our y-intercepts. And interestingly enough, it looks as if this isn't going to be linear because it's adding 1 and then adding 3. So that's doing too much. I'm going to assume that this is going to be moving in a quadratic increment because let's imagine that if you thought it was going to be exponential, you're saying that -4 times some number to the first power is going to get you -3. And you may be able to find that number, but is that number also going to take you to go from -3 to 0? Is it going to be that same number? It's probably not. So if you sketch this out a little bit more, we see that this line is going to go up like this. if we're assuming it's quadratic, we know that it's going to mirror. So we can also say that at -1, that outcome here is going to be -3. And at -2, it is going to be also 0. So we have two x-intercepts here. As far as a rule goes, we could say that the x-intercepts are helping us quite a bit. So we know that there's an intercept where x is -2. So if you plug in here, it goes to 0. And we also see another x-intercept here where x is +2. So this may be it. We could plug in and also see the other increments. I'm going to give you a moment to test out when x is 1 and x is -1 to see if those match. So take a moment and see if f of 1 and f of -1 match up. Show that arithmetic. Don't be lazy. You got this. So your work could have looked something like this to double check that f of 1 and f of -1, inputs of 1 and -1 match up to -3. So this equation does work. If you're feeling antsy, you could FOIL it out and get x squared -4. So you have two ways you could write that rule. Let's skip this one and see what else is happening on here. All right, so in the second part, this is a giveaway. We're being told that the function's linear. Again, it's going up or down like Tuesday. So there should be a consistent increment that keeps getting added here. So it just keeps adding 3. So 3, 6, 9, 12, 15, 18, line number 21. So as far as the rule, we started at 3 and we kept adding 3 x times. So you could say that this is f of 0 plus 3 times x. So that's one way you could write this rule. But don't let that stop you. Maybe challenge yourself. Think of how many ways you could write this out. Because we know that if we were at 6, we'd be adding 3. How many times do you think? Well, you're 1 unit away from 0. So you got to get rid of that 1. So you could say this is also your rule. You can do more if you want to. You could write infinitely many, however many you need to. What do we have here? We have 6, 5, 6. If we sketch this out, it looks like this. So when x is 1, that outcome's 5. It then hops up to 6 and 6 here. So it's probably going to be quadratic. Do you want to take a stab at this? What do you think this rule is going to be? How do you think this is going to continue? So this should seem as if it's just a modified x squared, basic one. That seems to be moving over 1, so to the right 1 unit and then up 5 units. If you plug in accordingly for where x is 3 and x is 4, and also where x is 5, that should get you 9, 14, and 21. If x was 6, you're pretty much taking 5 squared, and you're adding 5, which is 30. So this is one way you could write the rule. If you wanted to expand this, you could, but I just held on to vertex form because I noticed that there was a pattern of moving over 1 and then up 5. If this was not as wide for the quadratic, we might have had to think about what this a term here is. But luckily, our a term here is just 1. So there we go. Last one, it's exponential. So starting at 6, you did this in integrated 1. Not going to lie. You could find your common ratio if you take this, second term divided by that first term. So 3/6 equals 1/2. So starting at 6, you keep taking halves however many times for x. So you're just going to keep taking halves. So this is what? 1.5. Half of $1.50 is 75 cents. And I'll leave it up to you to get 4, 5, and 6. So I hope that this video was helpful. If you missed anything, if you were iffy on anything, please come talk to me, come to lunch and learn, say something sooner than later. I'm confident you can get through this material, and I hope you have a good time in the class. Thank you.